notes that we did. These are all quadrilaterals. They fall into the category of parallelogram. All these shapes that we've talked about, the rectangle, the rhombus, we're going to add the square into the mix today. Okay, the only requirement to be a parallelogram is that both pairs of opposite sides have to be parallel to each other. Okay, every shape underneath this follows the same properties. By definition, the only thing you have to be a rectangle is 4 right angles. By definition, all you have to be a rhombus is all 4 sides being the same. And then by definition, for the square is a combination of your rectangle and your rhombus. It has to have 4 right angles, and it has to have 4 sides that are the same. Now, all of these shapes follow all these properties that are just a basic parallelogram. Opposite sides are parallel on all of them. Opposite sides are congruent on all of them. Opposite angles are congruent on all of them. Consecutive angles will add up to 180, the supplementary. That's what that means, consecutive angles supplementary. And for all 4 of these shapes, the diagonals bisect each other. So we're just going to add into the mix what's also special about the couple other shapes that we've talked about underneath the umbrella of the parallelogram. So we're going to talk about the rhombus. So all the properties of the parallelogram, the definition, all sides are congruent. Okay, does anybody else remember anything that was special about the rhombus that we learned the other day? What's true about the rhombus?
It's like a half of each other.
Yes, like you got the 2 isosceles triangles that go into each other, they're equal. To do that, let me write this. Let me write 2 things. I'm going to write the diagonals are perpendicular to each other. Do you guys remember that? They intersect at a 90-degree angle. And because you've got those 2 isosceles triangles together, this is going to give me the other property. The diagonals bisect opposite angles. Let me draw you like a tiny picture to illustrate that. So if I'm just going to try my best to pretend this is a rhombus and all the sides are the same. Okay, if I draw a diagonal here, all these sides are the same, right? It creates, if I had drawn this better, these angles all have to be congruent to each other because you have 2 isosceles triangles stuck together. So along that diagonal, all 4 of those angles will be the same. If I kind of tried to draw this same thing, I'm going to try and draw it one more time. But I'm going to draw the other diagonal. So if I drew the diagonal here, still all 4 sides are the same. I basically just have another kind of set of isosceles triangles. These angles, these 4 angles would all be the same. Not the same as the ones we just did with the other diagonal, but if you have a diagonal, it makes every corner cut into 2 equal angles is what it's going to do. Okay, now special properties for your rectangle. The definition, just all the angles are 90 degrees in the corners. That's your definition. The other thing that's special about a rectangle, besides all the other properties of your parallelograms, is that the diagonals are going to be congruent. Okay, and then today we're going to add into the mix the square. Now, the square literally has all the properties of all these shapes. So all the properties of the parallelogram. Definition of the square is what I'm going to fill in for the next 2. All sides are going to be congruent, and all angles are 90 degrees. It also has, like the rectangle, the diagonals will be congruent. Like the rhombus, the diagonals are going to bisect angles. We're going to talk about that in the next example. And then like the rhombus, also the diagonals will be perpendicular to each other. So we're going to look at this first example just real quick here. Now, if I just have a plain square, like where your corners are, the entire angle here, that would be 90 degrees. Now, also, like the rhombus, the diagonals of the square intersect at 90-degree angles. So in the middle there, those would all be perpendicular to each other, so 90 degrees. They're going to give us an angle measure. I'm going to just kind of highlight it here. So here's D to B to C. So I'm talking about that angle. Does anybody know what that angle would measure? Like, what would the measure of that angle be? 45. How'd you get 45?
It's splitting in half.
Exactly. Exactly. So along that diagonal, like all these guys here would be 45 because the corner is 90. The diagonal bisects that. So if you just have kind of half of that angle, then it has to be 45 degrees. All I'm doing is taking the 90 and cutting it in half, and that's where you can come up with 45. 45 is half of 90. So if they give me this little expression, right? We got 2x minus 7. I just set that equal to 45 because that should be the angle measure. I'm just going to add 7 real quick to the other side. So I'm going to get, what is that, 52? And I would just divide both sides by 2 to get my answer there, so x would be 26. Basically, anytime you're working with the square, if you have the diagonals drawn in, all the corner angles where the diagonal bisects there are going to be 45 degrees. So 45 or 90, those are the numbers you want to use with the square. Now, if I ask you about, this one says angle AED. The diagonals are perpendicular to each other, so this angle right here, the whole thing AED, would be 90 degrees. So all you have to do to solve this question here, just take that expression they give you, has to be equal to 90, because that's going to be a square. Anytime you're talking about where the diagonals intersect, you got 90-degree angles. They're perpendicular to each other. I'm just going to subtract 6 here real quick. I'm going to get 7y equals 84, and I don't remember what that is off the top of my head, so I'm going to check. Should be 12 for your y value here. Does anybody have any questions? Okay, let's do a little bit of, this is kind of like a mixed review. So we're going to work with a rectangle here. Now, remember, if you have a rectangle, the corner angles are 90 degrees, but I'm going to do like a little something here. This triangle and this triangle will be exactly the same. And then the two triangles that I have colored in, or not colored, that I just left white, those would be the same. The diagonals bisect each other, but in the case of a rectangle, they're also congruent. Now they're going to give us just a couple pieces of information here. They say AB, which is here, is 6, and BD, which is here, is 8. Angle 2 is 65 degrees. Okay, now we're going to see if we can find some of these angle measures and some of these sides. So where is CD? So CD is across the bottom. How long would that side be? 6. Opposite sides are congruent, just like a parallelogram follows all those properties. Okay, AC, so the side across the left, what would the length of that be? 8. Perfect. Opposite sides have to be congruent. Can anybody tell me how you'd figure out the measure of angle 1? Yeah.
90 minus 65.
Exactly. 90 minus 65, which is going to give us, why am I doing this on my calculator? This is going to give us 25. The corner has to add up to 90 degrees, the entire corner. So if you know angle 2 is 65, angle 1 has to be 25. Okay. Let me hold off on this for a second. Tell me the measure of angle 3. 65. If you're inside, like these two have to be the same. If you're in the little white triangle, this one and this one would have to be the same. So where I've got angle 1 is 25, angle 4 also has to be 25. Right there, this guy also 65. And that corner still adds up to 90, right? All right, now, a couple of these sides I think are going to be a little bit tricky to do. So A to D. Let me see if I can kind of draw on this a little bit. Okay, A to D is one of the diagonals, right? The two diagonals are congruent, so if we find one, we find the other. Let me draw this to the side just a little bit here. The reason I highlighted that is because I'm trying to find the diagonal, but I've got this right angle in the corner because I know this is a rectangle. This is 8 and this is 6. Could you tell me the length of that other segment, or like how could we find it?
I think you can.
You can or can't?
Using Pythagorean theorem.
Yeah, Pythagorean theorem. That's all you're going to do. This would be that diagonal. I'll just put D for diagonal here, but this would just be Pythagorean theorem. Just be 8 squared plus 6 squared. The diagonal is going to be the hypotenuse because it's across from the right angle there. So this is a nice number when you do it. Let's see, I've got, this is 6436 is my diagonal squared. That adds up to 100. Does anybody know square root of 100? 10. Okay, so AD, diagonal, 10. Where's the other diagonal? Oh, it doesn't ask us. Oh, yes, it does. B to C. This would also be 10. All right, now, this is not terrible, but it's a little tricky. What if I just asked you for A to E? You know the entire diagonal is 10. If I just asked you for A to E, 5. It just cuts it in half because the diagonals bisect each other. So both of these pieces, A to E and B to E, they're just half of a diagonal, so it would just be 5. The whole diagonal's 10. You can always use Pythagorean theorem because you got a right angle. Does anybody have any question? Now I'm going to have you try one. This one's a square. Alright, so it says z to x is 8. So if this is a square, automatically I know all the sides are the same. So let's see, I can answer a couple questions just right here with what I labeled. Z to Y, I don't know that one yet. X, I don't know that one. I don't know that one. Okay, I guess I just know that one that I wrote down. Now, Z to Y is a diagonal. Okay, now this is kind of tricky, so let me have you guys do, I'm going to kind of do what we did on the last question. If you have a square, the angles in the corners are all 90 degrees here. If I want to find Z to Y, that's one of the diagonals, and both diagonals will be the same. We're going to do just a little Pythagorean theorem again. This one's a little trickier though because it's not a nice number. So I've got 8 and 8, and I'll just call that my diagonal. Alright, so I'm going to do 8 squared plus 8 squared. The diagonal will always be the hypotenuse because it's across from the right angle, so it's by itself when you set up that lovely Pythagorean theorem. This is going to be 64 and 64, which is 128. And these questions are going to ask you to leave your answer in radical form. So this is not a perfect square like it was on the last question. How do you guys like to break down a square root? To simplest radical form. Do we like to do factor tree? You want to find the biggest perfect square? Does that sound familiar? I think it's the biggest perfect square, but that's just an opinion. Do you know the biggest perfect square that'll go into that? No. Okay. I'll show you a couple ways to do this. So I like to pick the biggest perfect square, and I will be more than happy to give you guys a list of these. Perfect square, just a number times itself, and that when you take the square root, you're going to get a nice number. Is basically what a perfect square is. I'm just listing the first 10 there to the side. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, on down the list. Biggest perfect square that goes into 128, I would just grab my calculator and be like, okay, 128, and then see what goes into it. Of course, 1 goes into everything. If 4 goes into it, I would also check 16, and if 16 goes into it and you think you can get a little bit higher, I would check 64, and actually that's going to be the biggest perfect square. So if you would divide it by a number on this list, I will be happy to write that up for you. The biggest number on this list that goes into 128 is 64. So I just rewrite that real quick as 64 times 2. Okay. Does anybody know square root of 64? 8. That's my answer here. Just pull this out. This would be 8 radical 2 would be my diagonal. Now, the other way to do that, if you like a factor tree better, I'll show you real quick. You would break that into a product of its factors. So 128, I would just start with 2 and 64. You're looking for a pair, and I would say, okay, 64, I know that's 8 times 8. There's my pair. And then I broke that down, 2 would be left under the square root. So if you don't know the perfect square is super familiar, that would maybe be a quick way to do it too. But that's going to be my diagonal. So from z to y, I'm going to write 8 radical 2. And this one also is 8 radical 2. I'm just going to deal with the segments first, and then we can go back and deal with the angles. Okay. Now, extremely tricky. If I just ask you for r to z, that's just half the diagonal. If the whole diagonal is 8 radical 2, what would half of that be? 4. Exactly. Okay, so these guys, this one and this one are just 4 radical 2. If the whole thing is 8 radical 2, 4 roots of 2 plus 4 roots of 2 will add up to 8. All right, now I think the angles might be a little bit quicker. So remember, this is a square, so the whole corner is 90, but also the whole corner gets bisected. So angle 1, angle 2, both of these guys to add up to that 90 have to be 45. Anybody know what angle 3 is? Kind of in the middle. I'm writing all over the diagram. What would you tell me for angle 3? 90. The diagonals are perpendicular to each other. And then angle 4 down here is just going to be another 45. Is anybody having a question? Doing that radical breakdown is like the hardest thing you'd have to do on this homework assignment. Okay, now, the next little set, we're just going to see if we have a figure we can describe this.
So when would we use the radical stuff?
Just if it says leave in simplest radical form. If it doesn't, you could just use your calculator and take the actual square root and do the decimal. That's fine too. But I think it asks you for radical form, and we'll be definitely using that in our next unit. So I wanted to practice it with you guys a little bit here before we started.
Sorry.
Okay, now these next set, I know this looks like a lot of words, but it's going to describe something, and we're just going to say whether this could be a figure or not based on the properties it gives us. So I'm going to try and draw you a little picture here. This says a parallelogram has congruent diagonals and one angle that's 60 degrees. Okay, tell me what shapes that we've talked about have congruent diagonals. Rectangle's one. Do you know the rectangle and square? All right. Are any of the angles in a rectangle or a square 60 degrees? No. So this is not possible. All right. The next one, we're just going to kind of compare properties. Quadrilateral, so 4 sides, perpendicular diagonals, and 4 right angles. Okay, perpendicular diagonals. Do you guys remember which ones have perpendicular diagonals? There's 2. The diagonals are 90 degrees. Which 2? Square, definitely. The rectangle diagonals are congruent, but they don't run into each other at a 90-degree angle. It's a rhombus. Okay. Now, 4 right angles, right? We've got the square, and we've got the rectangle. So, I want one that fits both properties. I wrote square for both of these. So square would be this could be a square here, would be an answer there. Has to fit both of the properties. If you don't have one that fits both, then you're done. Okay, this one says both diagonals of a parallelogram bisect the angles. Okay, if you bisect the angles, that is rhombus, and that is a square. Okay, and then it lists the sides of the parallelogram being 5, 6, 5, and 6. Can either one of these shapes, rhombus or square, have those side lengths? The rhombus can have those side lengths. Why not? Why can't a rhombus have these sides, the lengths 5, 6, 5, 6? Why can't it have all sides of the rhombus? Exactly. Both of these, all sides are congruent. So this is a contradiction. This is not a shape that we could draw on this one. All right. Let me sketch a picture here. So this says we have parallelogram GRAM, and these are perpendicular. So if the diagonals are perpendicular, your options are square or rhombus. And it says GR is 16 and AM is 16. Is this possible? Am I creating any kind of contradiction here? I don't have information about the other sides, right? It doesn't tell me what they are, but this is not doing anything that's not okay, right? So this could be either one of these. This could be a square or a rhombus. It just doesn't give us any more information, but there's no kind of contradiction that's being created there. All right, and we're going to do one more. Both pairs of opposite sides congruent. So that's actually literally all. This would be parallelogram. This would be rectangle, square, and rhombus. All four of them. Okay. One angle measures 15 degrees. Okay, so if one of the angles measures 15 degrees, the rectangle and the square would both be out because their angles have to be 90. But I would tell you the parallelogram or the rhombus, either one of those could fit that for your definition there. So opposite sides are quadrilateral congruent, one angle is 15, just can't be a square or rectangle. All right, we're just going to stop there because we have a short period today. Don't worry about that last example. It was just